providers. The organization, our chairman is trying to join. He is facing some technical issues. In the meanwhile, for the benefit of time, we will start the session. I request Mr. Shivakumar from FLS to start his presentation. Thank you, sir. Over to you.
Thank you. Good morning to all. You are able to see the presentation?
Can you share it again, sir?
Yes. Is it visible?
Yeah.
I'm audible also, right?
Yes. Yes, sir.
Okay. Good morning to all. I am Sivakumar Natesan. I am in FL Smith, heading the process design and R&D lab, Chennai. And I am in FL Smith for the past 25 years. And I am in process design in my past roles and present role also. So today we will discuss about how we will be targeting low thermal energy in the clinker production, and what are the possibilities of doing small upgrades to achieve the benefits on the heat savings. We will touch three concepts like thermal energy savings through upgrades, through air blaster control inlet, ABC inlet upgrade, and how CB cooler change will increase the heat savings and also the WHR potential of the plant. And when we try to have a multiple option of using different fuels, what is the best possible way to save thermal energy in design concept itself. So we'll first go through the air blaster controlled inlet benefits. So we can see the picture like the snowman can be formed in the colder inlet, and it can be as bad as what you see in the picture. It may be the reason of the raw mix being going out of control, dusty clinker formation, red rivers prolonged at the inlet in the form of coating pieces. So ultimately, a snowman is forming at the inlet, which is not good for the operation. We have to stop the plant and then try to clean it. And that can be as bad as what you see in this picture. So when we know the causes for snowman, like raw mix chemistry going out of control, but how to prevent it from happening? We have the fixed inlet in the cooler to take care of the issues what we highlighted here, and also to give a better savings by making the recuperation efficient. But the previous design of fixed inlet, where the air blasters will have kept at the side, no, you will not be. 1 second.
Yeah, good morning, sir. Thanks for, sorry for the interruption, sir. Mr. Saxena, our Dr. Saxena, chairman, has joined. Welcome to you, sir. Can you please, are you able to hear us?
Yes, yes. Good morning to all.
Good morning, sir.
So sorry for the delay. I was not able to join.
I understand, sir. Sir, we have, good morning, participants. We have our session chairman, Dr. Saxena from JK Lakshmi Cement. He is unit head in Jajjar unit, currently heading the unit, and he has been heading various other units. He has decades of cement industry experience. Sir, what you, sir? We have four speakers from the leading technology providers, sir. What do you, sir? Mr. Shivakumar has just started for the benefit of time, sir. So over to you, sir. Thank you.
Yes, sir.
Sir, you can just, we can continue with the presentation, sir. Then
Yes,
sir
please,
can speak. Yeah,
please,
thank you,
please.
sir.
Yes, sir. Thank you, sir. Good morning to you, sir. And we will continue, sir. And this is the picture of the previous fixed inlet, where we have air blasters located in the side back wall. And as you can see that it has its own limitation of reaching at the center because of the distance. So when build-up try to starts up, we will be blasting it through the air blasters and try to remove it. But it is not so effective when we keep it on the side or back wall. So the new option of taking it is how to make the blasting effective. At the same time, if the snowman builds up, what will be the general reaction from the plant operators? How it is costing extra fuel? Because once a snowman formed, you can see that it is very difficult to remove even after the stoppage of plant. So once that got the experience from the plant, no, people will be very cautious and they will try to avoid the snowman buildup by maybe even overdoing the blasting. So they will not allow the material to pile up in the fixed inlet beyond a limit with the fear of snowman, and they will be trying to blast it much more frequently even than required. So ultimately, it is costing us fuel because the fixed inlet is the portion where the hot clinker falls down, and we should allow the sufficient time of the clinker to stay there so that the heat recuperation is maximized. So the caution of avoiding a slow man, maybe making the plant operators to overdo the blasting to make sure it moves to the next department, next session, and that costs fuel. So if you have very good control on how this snowman can be controlled by various means, good design, then definitely the benefit on fuel consumption will be there. And even if it is not reflecting in a day operation, if you take long-term operational data, a good control at the fixed inlet, which will not make the system operation to overdo it, will give the benefit on fuel consumption in long run. So the ABC inlet, which is air blaster control inlet, what FLSmith normally making as a standard for our new coolers, is a possibility of upgrading the existing plant also, where you can get the benefit of a controlled movement of clinker without having the fear factor of creating a buildups. And also trying to make the clinker to be there in the fixed inlet for maximum time to get the heat exchange done in a proper way. So the ability of this fixed inlet to upgrade in any cooler gives the benefit on fuel consumption and also on the operational maintenance point of view. When we try to upgrade the fixed inlet with ABC inlet, we will see the layout possibilities of making the modifications minimum and try to find the length and width of the ABC inlet fixed in the existing layout constraints. So longer the inlet, it is better because you are allowing the material to be there in the inlet in a controlled way, and the recuperation efficiency will be also better. But if the length is too large, too long, then the possibility of agglomeration and buildups is also there. So it will mean optimization of making minimum modification during the upgrade, at the same time trying to have the heat recuperation efficiency maximized without having the fear factor of snowman. So this is the ABC inlet grate design, where you can see that the regular airflow will be through the normal cooling airflow through the MFR and the blast air, whenever it's required based on automatic control and automatic adjustments of the sequence, it will blast the clinker, so that we can have a different way of settings based on the clinker chemistry, how agglomerated clinker it is, how fine the clinker it is, to have different sequence setup so that the air blaster control can happen at regular intervals. So it will avoid the clinker to get to a problematic area of snowman. At the same time, it will allow the clinker to be in the fixed inlet for the required time to maximize the heat transfer efficiency. This is the picture, a schematic representation of how it is being done. The green line shows the regular airflow, which is used for cooling, and the other one is air blaster control air. So the MFR cooling process is supplemented by an air blast released directly to the grates and the clinker bed. This eliminates snowman and prevents dead zones to be formed. We can have a lot of flexibility in blasting the zone at various build intensity, specifically applicable for the particular plant and particular plant chemistry. So this ensures that the clinker is distributed uniform throughout the fixed inlet. So by having the variety of sequence, it can be programmed and can be set up for the particular plant operation. So the operator will feel convenient that it is not going to be ending up with the snowman. At the same time, the clinker is allowed to be in this zone to maximum possible time, so that the heat transfer efficiency also can be maximized. So this is the fixed inlet, which we are telling that the number of rows and also on the length, how many rows it can be installed lengthwise based on the layout constraints without doing much modification in the subsequent compartments. This can be installed. Because you are blasting at the bottom under each grade, It is not having the limitation like the previous generation fixed inlets, where we are putting the blasting on the sideways, which is not possible to reach at the middle section. So it is like each grade plate clinker can be controlled, not to end up in a piling into snowman formation. And also we have different size of CB cooler, which is crossbar cooler. And you can see that we have a different option of how this fixed inlet can be made. Where when we see a smaller cooler, where the distribution of clinker is not a problem, we can have the entire cooler designed for a single fan. But when the cooler width becomes larger and wider and wider, we are specifically giving a separate fan for a drop zone area, where we are sure that clinker is going to fall and maximum cooling is needed. So it doesn't need too much control with an MFRs, and a separate fan dedicated to that is going to maximize the heat transfer efficiency, because that is the area where majority of the clinker is going to fall down. So the other areas will be controlled by with the regular MFRs and air distribution by another fan. So having a separate fan for the drop zone makes the total process control better in terms of avoiding the snowman and also getting the heat transfer efficiency to be maximized. So these are some of the parameters we achieved in multiple plants, where you can see that before and after modification of ABC inlet, how the parameters got improved. You can see that secondary and tertiary air temperature got increased, clinker temperature came down, and because of the better control in the fixed inlet, the bed depth control is also got better, and we are able to achieve all the parameters at a lower cooler drive speed. That improves the wear rate of the cooler also, because we are able to achieve a better production, better operating parameters, even with reduced speed of the cooler. We are able to allow the clinker bed to be formed at a larger bed depth without having the fear factor of agglomeration and snowman. So that helps us to recuperate even better, and that gives a benefit on the parameters. This is another plant where you can see that the clinker temperature dropped down considerably, and with an increase of tertiary air and secondary air temperature. So in general, the ABC inlet not only prevents the risk of agglomeration and snowman, but also increases the heat transfer efficiency, because the operator is a plant operation person is conveniently able to handle it. And this test was one-day test results, but when you take in a long term, in a month average, the benefit of ABC inlet will be much more, because with the varying chemistry also, the control is better. Hence, the long-term benefits on ABC inlet on plant operation is visible. So this is one of the best way of upgrading an option where we can save thermal energy. We have seen up to 15-20 kilocalories also saved in a plant where there is a frequent issues on raw mix chemistry, or the plant raw material nature is prone to create the snowman. Installation of ABC inlet created the operational benefit so that the heat transfer efficiency can be maximized. Then in crossbar cooler, we know that the special features is, as we just saw, it is air blast controlled, and it has stationary sealed grate line, separate cooling and conveying mechanism, and it has mechanical flow regulators. The particular point is it has a separate cooling and conveying mechanism, where the conveying is done by the crossbars and the plates are always stationary. So the performance of the cooler remains same even after startup and a few months of operation. So even before shutdown, if we try to take the efficiency parameter of the cooler, it remains intact. Because we have seen that some of the presentations or some of the inputs is like even after 7-8 years, the cooler remains intact in terms of performance efficiency. But it's also important that at which point of the time the performance efficiency is measured. If the performance efficiency is measured just after stoppage of the plant with all the updates done and then restarted, then the grade plates will be very intact. But when you try to move towards the operational time more months, if it is a grade plate design where the grade plates moves and conveys the clinker, the distance, the wear between the grade plates increases the bypass of air. So the cooler efficiency will deteriorate before the next stoppage. It will be performing comparatively at a lower efficiency. But because here separate cooling and conveying mechanism is there, the grade plates are remaining intact, and the efficiency of the cooler remains same. even after operations of few months. So it is not going to deteriorate. And this is a picture of a mechanical flow regulator under each grate plate in a CB cooler. This acts like a separate fan, which is able to control the airflow for the clinker nature above the grate in particular. So by the mechanism of the MFR's design, and the fan flow is getting distributed to the area where it is really needed, and it will not bypass to the least resistance path. You can see here, when the clinker is fine, it is going to create high bed resistance. So that is the area where we need to supply more air, because that is the density of clinker is much more, heat content is much more. But if you don't have any regulation, automatically the air will flow towards the least resistance path, low bed resistance, which is not required that much cooling air. So the material flow, so that mechanical flow regulators, based on its own design weight and also the pressure drops across the bed, it is going to act as a controller. So it is going to allow more air to flow through the fines area, and it will resist airflow through the coarser area, which doesn't need that air. So this distribution of air by automatic movement of mechanical flow regulators make sure that the air flows to the area where there is much more heat available, and the heat transfer efficiency will be maximized because of that. So this is a typical picture of a cooler balance, where you can see that you are putting around 2.3 kg of air to get a temperature of 95 degree plus ambient. This CB cooler has MFR that can be installed throughout the cooler. So even the last row, when it has an MFR with it, it acts as a recuperation cooler 100%. So particularly when we are trying to have WHR, even the mid-air, excess air heat is benefit. This cooler acts as a recuperation cooler, not only in the recuperation zone, but throughout the cooler. That is getting evident from using a lower cooling air. You can see that we are using generally close to 2.3 kg of air, when the previous generation coolers used to take 2.6. Even the old generation will take 3 kg for the same clinker temperature. So this is evident that for attaining the same clinker temperature, this cooler uses lower airflow, and that results in a high quality heat in the excess air, because you can see that the excess air temperature is 313. That is because the cooler efficiency till the last row is high, and the higher recuperation makes the heat transfer better. So you have high quality heat in the vent. And you can see that some of the coolers in the market uses more airflow, maybe 2.5 kg, 2.6, but at a lower pressure, because it's like a grate plate cooler, and that will result in excess airflow being higher and temperature also being lower. They may be able to save some power in the cooling air fans because of low pressure operation, and our fan power may be slightly higher, but the benefit on the slightly higher fan power is from the MFR control, and also the high quality heat you are going to recuperate in the recuperation zone, also in the remaining portion of the cooler. This helps us in getting the high quality heat transfer to the mid-air and WHR potential and all those things. You can see that we can take up to 0.8 kg and 380 degree as a mid-air temperature. Lower the mid-air quantity, the temperature can be even higher. But the parameter that can be compared is how much cooling air you are inputting to get the same benefit. If the cooling air flow is less, it means that the cooler is much more efficient, because it's using less airflow for the same cooling effect. And even the airflow, what we have seen here, can be recycled back to the cooling air to get the benefit of extra heat transfer. And we have an option of hot air recirculation also. One of the point which we try to highlight is whenever we try to recirculate the air, the drive model that is in the compartment, there we have to give ambient air only, not a recycled air. But the cooler design is having so much flexibility that these drive models can be moved between the compartments, and also can be used for maximizing the hot air recirculation. So you can see that generally with hot air recirculation CB cooler, the arrangement will be like this. Why we are not able to use the entire cooling air as hot air recirculation is because we need ambient air to support secondary air and tertiary air, because that air has to go back to the pyro process. So those air cannot be anyway recirculated. So we are able to recycle the remaining portion of the air 100%. So that all the air and heat exchange used in the cooler, except the heat going in the clinker, is getting utilized either in the secondary air tertiary air combination or in the WHR potential. So this normally we have seen that with full air recirculation and arrangement of the drive models, we are able to see 15 to 20% extra heat in the takeoff by making this recirculation option. And in general, as a parameter, when you try to evaluate a cooler, this will also indicate that the correct evaluation is going to give us a benefit on how to optimize the cooler. Clinker cooler efficiency is a parameter which being calculated based on some theoretical formula, but based on practical measurements. And this is a balance which we have done for a particular plant, where you can see that the pyroprocessing system requirement is 1 kg of air per kg clinker back to the system. So when you put secondary and tertiary air added together, it is around 1 kg, and the cooler efficiency is calculated and heat losses is calculated. So we will be able to take 110 excess air loss, and also clinker loss is close to 20. So these are the losses going out. But in the same cooler, if some process changes happens and we are trying to recruit, trying to take more air from the cooler, the 1 kg what we are showing here may improve to 1.1 or 1.2. We just redid the balance. If the quantity of secondary and tertiary air increases to 1.2, then you can see that the drastic reduction in the excess air heat. But the cooler efficiency has not changed. The cooler is not performing better. It is the same cooler, but by taking more air back to the system, the efficiency parameter looks to be better. But ultimately, if you see the realistic pictures, when we take more air back into the system, ultimately that air has to be heated in the burning zone, and it costs us fuel. So by just comparing the actual cooler loss, the cooler looks to be better. But when you see the real parameter which we are worried about, the heat consumption is high. So it's always better to have the heat consumption as the performance parameter to evaluate a cooler than the cooler losses or cooler efficiency, which is a good parameter to get the feel of how the cooler is performing. But it is affected by the other process parameters in the system also. So the last topic is how to design a pyroprocessing system when we have multiple fuels. Because we are designing particularly the market in our area is we can have an option of pet coke firing, imported coal firing, Indian coal firing. So when we size the calciner burner and the kiln burner, normally we size for all the three fuels that is possible to use in the plant. So if you are having a conveying system for this type of arrangement where multiple fuels can be used, the conveying air quantity is dictated by one of the fuel. For example, if you see pet coke, Indian coal or imported coal, Indian coal tonnage will be maximum for the same heat consumption. So the tonnage will dictate how much will be the conveying air required and what will be the size of the conveying pipe. Even though you have a variable speed for making the conveying air to be variable, but the pipe size, whatever you select, that needs to have a minimum velocity to be maintained to avoid the coal fluctuation. So when you design it based on high tonnage, based on Indian coal, your pipe size will be large to take care of that tonnage. When you operate in the other coal, like pet coke, where the tonnage will be off because the calorific value is low, it doesn't need that air, but for maintaining the pipeline velocities, you have to maintain a minimum airflow. So this is going to convey to the burner as a primary air, which is ambient air, and cost us fuel, and it may create issues in NOx emissions also. Many plants changes burners because to get the advantage on the lower primary air, but this concept of having multiple fuels designed with a larger pipe, conveying air being injected into the burner, cost us fuel and NOx emissions in a negative way. So this is a theoretical design calculation done, how it is impacting for us. So the plant A is designed for pet coke only, where the calorific value of pet coke is 8,000 kilocalories. And this needs a conveying air of 6,360 meter cube per hour. And when we convey this air and optimize the system, the expected fuel consumption is 692. If you keep this as a basic design of a plant, and that plant, if they want to operate even coal and also pet coke, and if they indicate in the concept of the plant design that it has to be designed for both, the Indian coal is having 4,000 kilocalories only, so the tonnage will be 2 times more. So the pipe size has to be increased, and the conveying air has to be 9,660. If there is a single line which takes this much volume, you cannot, even if you put a variable speed for the blower, you cannot reduce the volume beyond a limit, then it will drop the velocities too low. So you will be forced to pump more air through the conveying line because of maintaining the minimum velocity to avoid pulsating flow. So that is going to create extra airflow than required for the petcoke operation if the plant switches to petcoke, and unnecessarily contributes around 4-5 kilocalories extra. So our recommendation is have a separate conveying line for petcoke and coal and have a variable speed blower so that you can pump in whatever the air needed for conveying that particular tonnage only. Doesn't need to be extra airflow, which is a ambient air pumped into the pyro system. So we normally recommend to have a separate line for petcoke and separate line for coal with a variable speed blower, and use the correct conveying air so that you can get the benefit on the heat consumption and also on the NOx emissions. So these are some of the plant design parameters which we can look for an upgrade opportunities to optimize the fuel consumption in the pyro processing and the preparation of clinker. Even though the new technology like calcined clay saves the heat consumption in cement base, because calcined clay doesn't need that much heat like a clinker. And now in this presentation, we concentrated more on existing pyro system, how to optimize the fuel savings by making small upgrades, selecting a cooler of the correct technology, and how to evaluate a cooler. And when multiple fuel option is there, how to make the design to make sure that we are not spending extra fuel. So this is just a summary of design parameters and options of upgrades to get the fuel savings. So any questions, we can take it on the questionnaire session. And thank you for the support.
Thank you, sir. Actually, our chairman is again facing some issues in the connection, so he will be joining. Thank you, sir, once again. Mr. Balesh Kumar Singh, can you please start with your presentation, sir?
Yes. My voice is audible?
Yes, sir.
Okay. So, good morning, all. Good morning to respected chairman, though he is not online, but definitely we can pay regard to him. So, good morning to all panelists. Good morning to CI coordinator and all the participants here. So this is my pleasure to present here in CII conference one small presentation from me. I just share my presentation. Yeah, so good morning to all. Myself, Balesh Kumar Singh. I'm working with KSD Humboldt Vidag, India since last 15 years. I have total 30 years of experience in cement industry. Definitely, I have learned many things of all of you and with many of plants visiting and working in the plant. So this is my topic for presentation, that is sustainability in energy saving and productivity with advanced pyro process and grinding solutions by the KST. Hope my screen is visible, Mr. Khanna.
Yes, sir.
There is no any black spots there.
Everything is perfect, sir. You can move.
Yeah.
Yes, sir. Go ahead.
So today's scenario, when we see it is very competitive world in cement industry, not only a world, but Indian cement industry is facing more competition out of it. So definitely it has to be worked out for OPEX cost has to be cut down to survive in the today's competitive market. So pyro process is important area where we can save thermal energy, and in grinding sections definitely electrical energy can be looked for to save. With present situation, it is not only to save electrical energy in case of pyro process, but also there is scope to produce the electrical energy by the cogeneration in WHRS system. So as yesterday's presentation, our many of panelists has discussed already about the how is the thrust to use the cogeneration is being given by the government of India, and it will be it is mandatory to set up a waste heat recovery system. So in today's scenario, if we see one best optimized or well advanced plant, where we can see the total pyro process electrical consumption can be a 42 kilowatt per ton of clinker, and the same times it can generate 35 to 36 kilowatt per ton of clinker in net. That means only 7 to 8 kilocalories has to be used for to run this plant. But it is my belief that in next coming time, this also will be optimized, and the day will come when we say, okay, this is the uh, pyro plant where it is operating without taking any electrical units. So roller process has been proven its distinct capacity to grind raw mill with lower heat requirement. Hence, addition to waste heat recovery system potential is increased by 0.27 to 1.5 megawatt per hour. So that's why roller press is being accepted as a very efficient technology in comparison to any other grinding system when we are conceptualization of a pyro process plant. So it's now become very popular solution. It is being taken by many of the cement producers. Slag-based composite cement grinding requires lesser heat in comparison to other grinding system, which is making roll press more popular because it is almost equivalent to saving of another 2-3 units of power. So here we will discuss about latest pyro process solutions provided by KSD. So the recent development by KSD is done. I think it is in 2-3 years before, but now the time has come to uh, evaluate their performances. So Cyclone series was launched in 2018-2019, where these cyclones were installed, and high efficiency. These were meant for high efficiency and low pressure drop. So their results already started to come, that I will share in next slides. Then next comes KSD low NOx calciner with low pressure drop. Earlier we were facing some higher pressure drops in previous designs, but uh, as per time development in the technology, time to time now it is optimized up to 7 to 8 mbar, and it has also enhanced retention time, say 7 to 12 seconds in calciner. Utilization of long tube calciner for difficult burning of AFRs. NOx reduction by use of pyroredox reactor. So these all are the new developments. Pyroflow square cooler for high efficiency recuperation with highest reliability and low maintenance. So these are the new developments being done in the cooler. That cooler has to be more reliable when it is operating, and at the same time it must have the better efficiency and less heat losses. Pyro square Pyrostatic square cooler for highest degree of mid-air and recuperation air. And the next comes as a pyro rotor for enhanced uses of AFR, say 60 to 80% of calciner fuel. So this gives another degree of freedom to use any kind of fuel which are very difficult to burn, or their sizes are lumpy in nature. So this is just one brief illustration of cyclone development, how they are developed. So we can see here the earlier designs, the preheater pressure across the preheater was 36.6 mbar, but in the same equivalent series, that is now well achieved up to 25 to 27 mbar at the preheater exit. So this is the development that means now we can think about the preheater exit pressure can be maintained less than 30 mbar. That means 300 mmWg. So these data are for 5-stage preheater. We must not be confused with the 6-stage. Definitely 6-stage must be having some another addition of 5 mbar. So we can consider 35 or 32 mbar at preheater exit for 6 stages. So this is the real screenshot of the pyro process plant. As I said, this is now the time that result for the new developments are started to come. Here we can see the real pressure drop at preheater exit. We can see 190 mmWg is preheater exit pressure. Here we must not forget that this is for 5-stage preheater system. At fan inlet, it is 250 mmWg only, and preheater fan exit temperature is 295. That means this plant is not only efficient in terms of pressure drop, also it is efficient for the heat consumption. So when we get the information from this plant for heat consumption, they informed us that heat consumption is somewhere 720 to 730 kilocal for 5-stage preheat. So this was just a screenshot of a plant. This plant capacity is around 4,000 tons per day, but is operating 4,200 TPD. Next comes what are the developments being done for the in field of alternative fuel and their utilization. So here we have 2 or 3 types of utilization based on availability and utilization of AFR. So where we have less AFR utilization, there we can install incinerator, and this will definitely increase the utilization of alternate fuel by 10 to 12%. If our requirement is more than that, then we can use the calciner with combustion chamber, where we can use around 50 to 60% replacement of calciner fuel. But it also have limitation that the fuel sizes has to be controlled. But the next comes as a pyro rotor, where we can use a combustion reactor, which is looks like a very small kiln, which is installed at the inlet of the just above the riser duct in kiln section by a preheater section. But this reactor can very much accept the lumpy size of fuel and difficult burning fuels which can be fed, and the tertiary air comes along with it, which help definitely the burning of this fuel. So fuel burning can be controlled with the speed of this reactor. Also, we can inject a small portion of hot meal inside it. So this way it is being operated. Already around 8 to 10 systems are being operated all over the world, and many of inquiries are coming for this system. Next comes as a pyro redox. This is also a new concept in Indian cement industry. Definitely the rules for maintaining if it exit gases and their emissions are being very stringent in next coming days. Definitely the NOx norms, which are less than 600 milligrams per NFU, are going to be more strict in next coming days. So in that case, either we have to use the ammonia spray at the calciner, or we have to think for any alternate. So this is the alternate where there will be no any OPEX cost like ammonia spray, and there will be no any hazard to handle the chemicals. So this is a loop which is additional to the calciner, and there it is being maintained NOx reduction technology. That means if we see in the loop, the kiln inlet, the NOx are coming into the pyro redox loop, where we maintain reducing atmosphere. That means lack of oxygen in that area. Definitely there will be some CO percentage, but this will reduce the NOx which are being generated from the preheater, and then it enters to the calciner where we inject the tertiary air, which was earlier reduced condition. Now when it comes to the pyroclone, it becomes oxidized, and the calcination comes as per the normal calciner principle. So this way the NOx is being reduced by 30 to 40%, which was produced inside the kiln, and the norms which are required can be fulfilled very easily. So these are the photographs of real installations at the various plants, and this is the installation at Indian example in Chettinad Cement, which is already being operated, and this plant is successfully handed over. Next comes to the clinker cooler. So definitely cooler is a very important equipment for any pyro process plant. So in new cooler, it is made second generation of walking floor cooler. Earlier was first generation, but in second generation, what is taken care especially that it made more reliable and must be most robust. So modified cassettes and sealing design, pyrostatic grade, optimized chamber sizes for improved heat recuperation and efficient cooling. And what are the main advantages of this cooler? That it can be operated on higher clinker bed. Means it can very much operated 900 to 1000 mm, which definitely reduces the any escape of cooling air, any short circuiting of cooling air. So fully cooling is being utilized. And next improvement is done in hydraulics. That means they are made more robust so that there should not be any issue comes the transportation. So these are the example where it is shown that what are the effect coming if we are using clinker bed 800 mm and when we are using clinker bed 1000 mm. So when we are using 1000 mm clinker bed, our cooling air amount reduces up to 1.65 to 1.7 nm cube per kg clinker, and when we are using a clinker bed less than 800 mm, then it may require 1.8 to 2 nm cube per kg of clinker. So this is a one photograph which are showing the pyro step, which is a mechanical arrangement of a cooler, but it can be also given with hydraulic drives. But the transportation is not being done by pneumatically. Transportation is done by the great movement, that is mechanical transportation. So here there are two options where we can use mid crusher. Mid crusher where we expect some lumpy clinker formation. It all depends on the clinker chemistry, where if we have high fluxes and clinker higher magnesia, or where we expect that lumpy clinker may be formed. So when this clinker is leaving out of cooler, definitely it is taking some heat out of it. To take all the heat out of this cooler, it is clinker that is better to press it at mid place and take all the heat into the mid air. So this is very much successful, and almost 0.5 megawatt in enhancement is found in the waste heat recovery system. So next comes on the grinding technology. Definitely grinding technology plays a very important role when we are talking about the power saving and efficient plant operation. So what is done in latest designs, that we have made the compact circuits. That means the building height is tremendously reduced after work of many of years. So what it attracts, the power saving breakup of RP circuit in raw mill, additional power generation by waste heat recovery system, power saving of 1.5 to 2.5 kilowatt raw mill in roll press circuit in comparison to other grinding circuits. All put together, clear cut 2.2 to 3.2 kilowatt per ton of raw mill power saving in roll press circuit. So due to all these above regions, it becomes very much popular in recent years. Total power consumption for pyro process that already I explained in previously that there is hardly few units difference comes from power generation and power utilization. So this is very much interesting experiences with the roll press in finish mode in composite cement in slag grind. Earlier it was assumed that in roll press the composite cement grinding may not be feasible or it may not be economic, but definitely this is being done and it is already running successfully since many of years in many places. So this one example I'm sharing from it is from Bangladesh where a roll press circuit was supplied with 160 TPH guaranteed, and it was for clinker, gypsum, limestone, slag, fly ash. These all were constituents. So it is working all together, and the production was guaranteed less than 5% on 45 microns, which was very much achieved. And the plant is running successfully at 163 TPH, which was given during the performance test. So you can see the product finance is less than 5, that is 4.15%, and power was 21 kilowatt only. And when it runs with composite cement, the production was 245 TPH and less than 5% residue, and the total power was 24.5. This is the real screenshot of operation of roll press in finish mode, where we can see 163 TPH, and this is for semi-finished mode when it is working with ball mill. But recently I have collected some more plant data, which is nearby this plant. So this is one recent screenshot. You can see it is yesterday's screenshot where one 4.6 meter diameter ball mill is connected with RP16, the same RP, which is having 1450 kilowatt motor. This is altogether is operating 360 tons per hour, and this 360 tons per hour is all the ratio mix. Raw mix are the same, means clinker, gypsum, this is limestone, this is fly ash, slag. All together these are working, and at this level the product fineness is less than 6%, and the total power for this circuit is coming 24 to 25 kilowatt per tons. Here we must know that when we are using ball mill, then there will be some power consumption will be there. So if it is only roll press, definitely it will be 21 to 22 kilowatt. But when it is all together with ball mill, the power consumption comes 24 to 25 kilowatt per ton. Here, one thing is interesting that ball mill is 2-chamber mill, and we are using the bigger media. That means whenever roll press is stopped for maintenance or any other purpose, ball mill alone can be operated, and in case ball mill is stopped, roll press alone can be operated. So this is very much flexible system, and need not to change anything, any grinding media or anything. Here I would like to inform that it is only possible because in that ball mill the grinding media is utilized less than 70 mm, and that happens because of the softer clinker grindability and smaller size clinker. Otherwise, if clinker size is bigger and clinker is harder, then we have to utilize 90 mm balls. That will definitely increase the power consumption for this system. So these are the just sharing what I have shared, that with references to gauge the latest pyroprocess technology development and additional to WHR, it becomes possible to become power free clinkerization. So that definitely it has to come. That one plant will be power free. At present, yes, there are utilizing 5 to 7 kilowatt that has to be taken out of the grid. It is very much feasible to optimize total power from pressure to storage by 2 units. Roll press in finish mode in Promil have proven its importance with power saving up to 3 units. If clinkerization becomes power free, then only cement grinding required power, which is about 27 units. And roller press in finish mode for slag composite cement has been established, and it is very much possible that the next time which is going to come, definitely there will be more things which can be done for cement industry. So this is all from my side. Thank you very much for your valuable time.
Thank you, sir. Thanks for your excellent presentation and giving us the latest numbers, mind-blowing numbers. Earlier, above 3 was the unit for pre-refan. Now you are saying like 2.8 is already achieved. Thanks for sharing all the information, sir. Mr. Lakshmi Narasimhan, can you please start your presentation, sir? Thank you.
Thanks, Murali, and I'll share my slide. Murali, are you able to get my slide?
Yes, sir. Can you make it full screen?
Yeah. So got it?
Just loading, sir. Yeah, fine, sir.
Yeah. So, Mr. Murali, thanks for giving us opportunity to us, and thanks, Mr. Saxena, the session chairman, and as well as the panelist presenters. So this is Lakshmi Narasimhan. I'll talk about the energy efficiency improvements by giving retrofit solutions for the key critical main drive, which is kiln main drive, which is called the heart of the cement plant. This one's. So I'm Lakshmi Narasimhan, having 26 years of experience, right from the DC machines testing, design, manufacturing, then drive systems of low voltage and large voltage. Also having the expertise of designing the high voltage and low voltage drive systems for the cement plants from the cement engineering company, and with Siemens now almost now I'm 15 years now. So this was my experience, and today I will start with the technology to transform the everyday. So as Mr. Shiva as well as Mr. Balesh says that today's scenario, it is very essential to reduce the operating cost of the cement plant and taking their operating efficiency to the higher. Thus, it can be giving the better future green environment to our next generation and society. So with this, so I'll start my slides. That is that ME motor retrofits, the approach by us towards replacement of the outdated DC main drive systems for the kiln in cement plants. So why retrofits required for this is that today how to increase the plant operating efficiency from the old DC machine, something around which is a 30 to 40 years old technology, still it is running, and how the equipment can be have higher reliability for the operations of the process and keeping the low maintenance and operating costs to the plant and the end users, and also providing the sustainable green environment for the future. So upgradation, what we do, upgradation means that the DC and the slip ring machines in the cement plants for various applications. In old good days, it was supplied with the latest squirrel cage induction motors on the drive systems. And upgradation gives energy savings with the special design machines based on the operating load and operating conditions, and also considering the future plant enhancement capacity levels. Also should have the easy maintenance to the end user department, and as well as meeting their planned cost operating budget, and also have less CO2 emissions, and also have opportunity for them to take the new PLI incentives, which is announced by the governments also. The failures, there are a lot of failures, frequent increasing of operational failures in the DC machines of commutator segment rise, or the brushes getting faster worn out, or the pigtail cuts, and also sparking between the commutator slots. Lot of this kind of operational failures, and how it can be get reduced so that the plant operating downtime can be kept high. And spares, also critical spares for the 20 years, 30 years old supply machines, be it the commutator or the service of those equipments at periodical conditions become a issue. And also how within the plant the equipment can be interchangeability for various key critical applications also. So these are all the topics why retrofit is required. So we will go on this. So in retrofits, when we are doing for the retrofits for the kiln main drive or for any this thing, so here I'll mainly focus on the kiln main drive. What is the modern approach, the step-by-step approach we used to do? The first is at the electrical selections, which means when I say the electrical selections, know about the entire the present equipment of the DC machines, its the technical data sheets and its operating parameters, and also the operating process parameters of the plant here, right, with respect to kilowatt, voltage, speed, then the input torque at the kiln main inbox, main gearbox input shaft, then as well as what is the present plant operating capacity, kiln feed rate, kiln the clinker output rate, and what is the customer future planned enhancement capacities, whether the drivetrain systems can be suitable and rightly dimensioned for his future capacity. So this was the electrical selection we used to do first. Then after the electrical selection is done, then the mechanical suitability. So how the end user can keep the same concrete foundation blocks, foundations, without changing, disturbing that foundations. We all know that any change in the concrete foundations in the 3-tier support kiln or 2-tier support kiln will become a big havoc, and no plant people just like that will accept that one. So without touching that one, how we can able to give the right solution to the customers, interfacing with the existing foundation and coupling, be it the coupling between the main motor to the main gearbox, then the foundations and matching dimensions without disturbing that support which carry that the kiln hot air to the pyro. The third is that the site suitability. By visiting the site, that check for the space constraints, as I said, with respect to the all that the major touch points, like the layout requirements, cable entry, cable terminations, then the space for the easy space for the people walk away, so that, and also for easy space for the in case of removal of the machines and the installations and directions for easy maintenance. Then with all the three is there, then we do the right solution design of the machines with respect to the as I said, the plant feature capacity, machine suitability, and matching the dimensions of mechanically, and also bundling the solutions with the right motor along with the right selection of the coupling, total coupling, as well as giving the entire the drives, electrical drives also apart from motors also. Then once it is arrived, it is presented to the customer and finalize the deliverables with respect to customers, and take their inputs. In case of their inputs, accordingly revisit the entire the step 1, 2, 3, 4, and finally do the technical LOR, technical MOU. This was the step-by-step approach we used to follow for the retrofit of the kiln main drives, as well as some of the other large process fans which was running in the slip-ring machines also. So with this, I will move to some of the classics examples in the recent past in some of the largest cement plants for the kiln main drive, and how we did this also. So if you see the next slide, that this is a classic case study example of retrofitting of the old DC machines, where the plant capacity was around 5,000 400 capacity they are able to run, because original design was 4,800. They are operating the clinker output of 5,300 to 5,400, and they want to have a future enhancement capacity of to go up to 6,500 for the drivetrain these things. So if you see in the picture here, you can also see that there was an old motor and as the new installed motors. So here what customer has faced the challenges. Here is at higher maintenance cost. This is one how we can able to reduce this cost, because this is almost 20 to 23 years old DC DC motor running with the water force cooled machines. So we all know that kiln is high operating hot zone, where the ambient temperature, if you go down, it should be always between 50 to in between 45 to 55. Sometimes during peak peak summer period, it will be touching 50 plus. So always the kiln, that's why always the kiln main drive system is designed for a 60 degree. So there, if you pump, if the motor designed for a water cooled, think about the process people in the plant, as well as be it electrical or be it electrical, delivering the water at the cooler inlet of the motor, something around between 30 to 35 degree temperature has become a very big havoc. So that you think about the temperature of the water which they have to pump from the chiller plants. So these are all the additional headaches customer faces, the challenges, and this one. And also getting the spares, like if you see the carbon brushes, then the commutator, then the changing the commutator periodically over a period of time of operations, then pigtail cut, then the brush burn out in particular rocker arm or the these things. So these are all the customer has expressed the concerns. Then we visited the plants. Then what we did. So we did is that we made a compact motor design. You can able to see in the picture also. It's a Cementech such compact design machines. We designed the machine with TFC design with efficiency of 97.6% was guaranteed, including the blower circuit also at 75% load. We all know that the kiln main drive always run with between a power of 45% to the maximum of 68% of its rated installed power capacity, because of its very high over capacity design to take care of its starting and sometimes the operational running requirements also. So here we have inform the customers after visiting the sites and evaluating the existing machine drawings as well the foundation drawings, layout drawings. We confirm that no critical dimensions at the foundation is no need to change, and the critical dimensions are matched with our solutions with the motors and that sole plate solutions to the customers. So we also provided the complete the coupling between the motor to the gearbox input shaft as a solution to the customers also. So also we also given the customer to give the confidence of the testing of the motor temperature rise test in our advanced motor test center in our Kalwa works, including the overload. Normally kiln, you see that during startup it requires overload of 50% for 60 seconds during startup, and also it is designed for 50% for 60 seconds on every 600 seconds the load. So this load during startup, when the kiln is getting starting, like the motor will get start with the 50% overload, get for 60 seconds, it comes down after that. If you see the curve also, it is shown in the bottom of my slides also, right hand side. So during the running operation at rated load, at rated torque output, at rated speed, it's also able to take the go to the 50% load for 60 seconds and come back. So this cycle of around 3 to 4 cycle was demonstrated to the customer by loading the direct method on these machines. So what finally the customer has got the value to the customer. Less maintenance and operating cost, yes, by having a water cooled machine, pumping a water flow of something around 430 liters per minute to the heat exchanger of that existing the old DC machines to the air cooled machines, less maintenance and less operating cost, because of the higher efficiency of 97.6% versus the armature circuit, including the blower, including the filled circuit of the old machine was something around close to 93.8% was efficiency at 70% load. This is as maximum efficiency was considered for calculation purpose by the customer side. Then The total energy loss on the machine, on DC machine, was close to 97.8%. 97.8 kilowatt is the energy loss was earlier machine, including the chiller of 11 kilowatt 4-pole machines. Then against that, with the new machine was installed, the total losses come down to 31.2 kilowatt. So the total energy saved by the customer, old machine, including the cooling blower circuits, then
Sir, your voice is not audible. Hello? Mr. Lakshmi Narasimhan, are you there? Mr. Lakshmi Narasimhan, we are not able to hear you.
are you able to hear? I am able to hear you.
Yeah, now we are able to hear you. Yeah, go
Okay.
ahead.
Yeah.
We heard you up to the savings.
Yeah. Are you able to see my screen now? It is visible?
Yeah, visible, sir. Yeah, go ahead.
Yeah. So the customers have an annual saving of around 67 kilowatt versus the DC machine, so the present installed one. So he able to save 67 kilowatt, and the cost of annual energy a total of something around 5,34,000 units was saved, and indicative cost of taking 8,000 hours operations in a year at cost of 5 rupee, 5.35 or 5.25 rupees. Indicatively, it saves 2.2 million INR per year. Also, it saves that for around 400 plus tons of CO2 emission reductions by going for a higher efficiency machines. And with this installed motor, the customer also able to have a 40% higher production he can able to do with the same drive systems also, with the keeping all the parameters within the limits. So this is a classic study we did, and we also commissioned, and our entire team was there at the site. Still, it was handed out to the site. This was almost running successful, almost now 9 to 10 months now. So I also will go to the another one more case study. Another one that in here this customer had almost 34 plus years of the old the machine systems, DC motor, DC system supplied from Germany. And here the customer had an existing machine of IC 516, which is this plant was around 3,400 clinker output capacity, and the kiln was 3.6 by 61 or 62 meter length, if I'm right. So here the customer had a DC machines, and he wants to change the entire DC machines of present for the kiln main drive, Regulator fan, and the back filter fan. Those two fans were running with the slip ring motor systems, and kiln was running in DC systems. So this was a proposal given from Siemens side that we will change all these three systems with the TFC machines, with the high efficiency machines, with the medium voltage drive systems for the kiln, as well as the preheater fan, as well as for the back filter fans. So as I said in my earlier slide, the customer has got an efficiency of same again 97.6% here also here, because we kept the design ourselves. Maximum efficiency between 60 to 70% is almost flat because of the nature of the kiln operating that particular operating load. So here in this case, the customer is able to save the energy of something around 20 to save around 18.5 kilowatt was his annual savings, because the rating was less, and existing also was with IC 516 cooling machines of TETV designs in DC concept. Total annually he could able to save almost approximately INR of around 600,000 rupees was able to save. And this motor was designed to capable of having the maximum production of from present capacity plus 35 to 36% can able to run with this present systems. This was this one. And here in this case, this machine Siemens has supplied entire the motors plus the solutions of matching the existing dimensions as well as matching the coupling dimensions. Also we supplied with the like yesterday one of our panel in the second of one of our team member has presented on digitalization topic, that we also presented the supplied the drives with the C drive IQ with all the other the features of taking the data to the cloud. C drive IQ Connect 500 was supplied as part of this also. This also become now distillation has been taken off this one. One of the first plant in the India has connected this distillation for the kiln main drive, and also it has been data also been is coming to this one, and there's a real benefit to the customers also. Last but the least, that so far if you see that we have did retrofits of almost 80 plus installations in various sectors, the key sectors: cement, metals, the paper, and the sugars also, from 35 plus customers, and also in domestic as well as 3 plus over 6 customers from India. And therein, as I said, that 20 plus installations in cement plants, majorly in the cement in the kiln main drive, as well as the some process large fans also. So I also, as I said, that we deliver the Siemens products, the motors, drive, and that complete solutions with the digital capabilities, and even customized solutions like application like the kiln main drive or the roller press, the retrofits with the digital solutions with the remote or on-site continuous monitoring services has been provided from Siemens side. So with this, I thank you for the opportunity once again, Murli, and as well as to the chairman, session chairman, and my contact details is there.
Thank you, sir. Thanks for your presentation. And then I think all the existing plants with the old drives can definitely look into the opportunity of changing that with the latest system. Thank you very much, sir.
Yeah,
Mr. Vijay, over to you, sir.
Can you see it, please?
I think it is loading, sir. Give me a minute. Not yet, sir.
I've loaded.
Can you unshare and share again, sir?
1 minute. Can you see this?
Yeah, we are able to see your desktop, sir.
Yeah, oh, okay, right. Can you see it now?
Yeah, sir.
Yeah. Can you see it full screen?
Yeah, sir.
Yeah,
Perfect.
thank you very much. Thank you very much. Sorry for the inconvenience. Good morning, everyone who is online. It's a privilege and honor to be presenting on the CII platform on this a very important green cement tech webinar. Over the last, yesterday, we had our industry leaders presenting the vision up to 2050, both from an industry perspective as well as from an environmental perspective. And we had the technology leaders, which we have heard even among our panelists, presenting the various technologies for the future and currently to help us reduce our energy consumption. Right, but for an industry, for a plant perspective, how do we go about doing whatever our leaders ask us to do? That is the key topic that we'll be addressing through our services in SRSMES. SRSMES, we are a 9-year-old company. We have a small boutique consultancy. We have done up to 120 process audits across all the OEMs who are presenting in this seminar and those who have not presented. We have experience of system audits among all the OEMs. We have so far executed almost 26 projects across the spectrum of all the sections of the cement process. We are basically into cement plant design and engineering, plant audits, cement plant consultancy services, modernization and upgrades, training and development, process support services, NOx, WHR systems with HAR, alternative fuels, and CFT. That's what we are. And me, Vijay, I have 40 years of industry experience. I've worked with ACC, Blue Circle, Lafarge, Holcim for almost 25 years abroad. In the field of process engineering, projects, technical support, business management, etc. Currently, I'm working with SRSMES. What do we bring to the table? Before we speak about it, let us look at the net zero challenges. What is the magnitude of the task? You know, yesterday we have listened that in India, we have 3 types of plants. One, which are very progressive, leading the initiatives to energy, net zero initiatives. Then there are plants which are just waiting and watching. And then there are plants which are just saying, I don't care or I don't know. So we have a spectrum of what you call approaches among the various industry plants. In addition to that, as one of the biggest producers, we have 210 large cement plants, almost 550 million ton. So the impact is quite huge. But along with the challenge is that almost 50% of the capacity is almost 20 years old. That's, you know, built in 80s, 90s, etc., where it is not, they are not designed for the kind of fuel mixes and product mixes that we want to produce over the next 5, 10, 15, 20 years. As yesterday GCC was mentioning that unless we do kind of an upgrade and utilize these technologies in 10 years and make it happen, it may not be possible to reach the net zero ambitions. Currently, we are only at 70% of utilization. So still there is a 200 million tons of capacity that needs. And we have the challenges of various technologies. You know, the European ones, which we have been listening from the panel, is the Chinese, the Indian, and various other low-cost countries. From a fuel perspective, unfortunately, in India, we are quite low in the overall utilization, only 4%. The benchmark figures that the CII has produced, you know, the numbers that we see, only 10 to 15% of the plants are really at that particular global best performance. The rest of the plants have still to catch up, and that requires high investment costs. And yesterday we heard about high interest rates, lack of capex. So how do we facilitate a solution with lean capex while meeting the environmental needs, the profitability of the business, etc.? Now the challenges, here we speak of only scope 1 emissions of the net zero. That's what the plant produces, mainly around specific heat consumption, power, alternative fuels, waste heat recovery. The bulk of the challenges, as what we see based on our experience auditing the plants, operating the plant, the older plants are not designed for high AFR. They are not designed for high TSR. The fuel variances last year and this year has given a very good shock for the industry, where there is a high variance of source, quality, and prices. Where yesterday Mr. Singhania was mentioning the cost of energy in the cement production has gone up from 800 rupees to 2,000 rupees per ton. That's the kind of a challenge from a business perspective. Then there are technical perspectives that we have to address. So as a service provider, what do we bring them? And what do we see? We see intraday variations, day variations, and seasonal variabilities. While the yearly performance shows quite a consistent number, surprisingly, when we audit the plant, we do find a lot of variabilities. We do find reliability issues, productivity issues. Then we find difficulties. We have a lot of new technologies, modern technologies that are bought at a very high cost. Are we able to operate them consistently, etc.? If we are not, then we find significant gaps in the operational systems. Then from a team and skill perspective, most of us are basically production oriented rather than process or system oriented. That are the challenges that we see on this one. Now, if you look at where do the Indian plants stand, there is a lot of thing to catch up. Even among the best, the variable yesterday's CII presented almost 115 pages of benchmarking figures. You can see even on the top, there is a lot of variability. On the alternative fuels, there is a lot of catching up that we need to do. So what is our methodology of navigating our clients? When the clients ask, what should I buy? What are my requirements? What is the kind of a technology that would suit me? Would it fit into my plant? And what are the real gaps from a business perspective and a technical perspective? What we see is that we have to audit. That is the first approach. Then we do the process adjustment. Then we look at the optimizational part of it. Then we retrofit, and then if required, replace. That is our methodology we look at it. For example, if we look at the specific heat consumption, what we see in our process audits, we have 3 different cluster or types of plants that we normally say. The plants which are old, with a high heat consumption, which are needing optimization and upgrades with retrofits. Most of them are older than 20 plants. Then there are very modern plants which are running to full capacities, very good heat consumption, etc. But they are ready for the newer technologies, artificial intelligence, and various other things. Then there are plants that need optimization and SSC evaluation, retrofit. Here, what we find strange is that some of these plants display highly consistent specific heat consumption, irrespective of their capacity utilization. That gives us a requirement to evaluate what is the real heat consumption that they have. And until we evaluate the real heat consumption, we cannot recommend retrofits. Then we also see, when we evaluate and recommend retrofits, it's not an audit of 1 or 2 days of site visits and audits. We look at the historical data and to see how is the long-term deterioration or consistency of performance of these plants. If there is a long-term deterioration in productivity, we need to address this thing. Similarly, on a very short term, we find intraday variations. Mostly what we get from a plant is that, this is our average fuel consumption, average power, etc. But when we look at the opportunity, when we want to look at the opportunities and the reasons and what adaptability of a retrofit, we look at much more closely. We look at the intraday variations of operational KPIs that are impacting the capacity or the heat consumption or the power consumption, etc. So similarly, on the specific power consumption also, what we see is that there are large variations, especially on power consumption around me and etc., which are we see a large variation up to 20%. Imagine a large 20% intraday variation. It has a huge potential for savings. And what do we do with all this data? People, when the plants ask, we need a retrofit, we need to buy in a new technology, new equipment, etc. We have our own designs, but we also supply. We work with all the OEMs to give the correct equipment to them. But before that, our solution is focused on first is the process fine tuning, optimization, and then required. Okay, you have done you have optimized your plant. Then we look at the new technologies or new retrofits that will come into the picture. Now, from an AFR perspective, India, we have taken almost 15 years to reach 4% TSR. There are technological challenges, definitely, but there is also AFR usage impact. It is still not fully captured in India. At 5% substitution rate TSR, our productivity loss is hardly 1%. Our ambition is to go to 60% and 100%. At 60%, the productivity loss could be almost 7-8%. At 30%, it could be 7-8%. At 60%, the productivity loss could be almost up to 15%. So then a corresponding impact on specific heat consumption, the specific power consumption, that automatically increases. So that has an impact on all the equipment, in terms of fans, calciners, dedusting systems, everything, etc. In addition to that, from a technology, from an equipment supply perspective, we have to address the AFR variability. Most of the plants that have delivered a higher TSR in India have basically been able to get that because they were able to get carbon black. They were able to get dollar chart, but that's not, or plastics. With the change in the regulations on the plastic, obviously the future is almost on RDO, refuse derived fuel, or MSW, etc. Then there is an issue of the type, the quality, the CV variations, and the moistures and the granulometry. Plus, yesterday Mr. Saxena was presenting, because the price of fuel has gone up, the price of AFR has also gone up. So that's so given this constraint where the quality is not really consistent, this is the next challenge that we normally encounter. Now, when we have only MSW, when we have audited a plant, this is a typical plant that we have audited, which was having almost 25% TSR. In the intraday variability is quite high. The quality and the high moisture content. Mostly what we see is that when we are looking at TSR, this is one thing that we do not really control. That's the moisture that we are firing into the game. It has a significant impact, right? Normally MSWs in India, we are getting almost 30-35% moisture. And that effectively, even though we say that we are at TSR of 24%, the effective TSR becomes almost 10%. That has an huge impact on the specific heat consumption and the gas volumes and the flame temperatures. So obviously it basically reduces the capacity of the calciners, burners, the process fans, etc., etc. So given that this is a challenge that will increase as we are targeting a higher heat TSR from 5% to 20 to 25% or higher. So what is the way forward? Obviously, the plants which are younger than 20 years, they're more designed with the calciners, etc. They can be optimized. They can do the new technology replacements, and they can accelerate AFR. And plants which are older than 20 years, first there is a need for optimization. Then the next thing that comes up into their retrofitting, because the AFR adaptation has to be slow. So what do we bring to the table? We assess the requirement of the client plans and need. What is their capability? Yes, the technologies are available. Does it fit into you? Does it suit you? Does it suit your raw mix? Does it suit your layout? Does it suit the various other fuel that you are using? The availability, the feasibility studies. Then the process design engineering for resizing, retrofitting, and replacement of equipment. What needs to be, what can be replaced, what can be resized, and what can be retrofitted. Then the selection and supply of equipment, which are needed for pre-processing. We also advise on the pre-processing equipment. You know, what kind of shredders are needed? Do you need a secondary shredders at this stage of a TSR? Do you need an AFR dryers? What is the requirement? What kind of a size fraction that we will be able to add? We support on commissioning and optimization. All right. On our experiences, I just shared the project that we have completed. We have done quite a few upgrades, you know, varying between 3,000 to 6,000 TPD across all the OEM plants that we have, that we project, you know, major FLS, KHD, polishers. Most of the plants we have retrofitted. Currently, we are doing 3 projects. 2 projects at Dalmia, we are upgrading their kiln from 5,500 to 7,000 TPD with 35% TSR. We are also doing one upgrade in Kazakhstan, 2,400 to 3,000 TPD without calciner. It's a mix of various jobs from cyclone replacements, calciner modifications, and the whole pyro system upgradation, including cooler upgradations, etc. Similarly, on the grinding systems, we have done a lot of retrofitting jobs across all the major OEMs mills, you know, from Lucia to FLS to Thyssen, Pfeiffer, Walchenegger, etc. We have done coal mills, raw mills, cement mills, etc., with significant savings in power consumption. Currently, we are upgrading a project in Kazakhstan, which is on closed circuiting of cement grinding systems. All right, we have a repeat orders also on that. All right, on the process audits, as I mentioned to you, we do the process audit. We have an experience in 9 years. We have done 120 audits, roughly audit a month. That's our experience. We have audited plants from 1,500 TPD to 10,000 across all the OEMs. All right. And these reports, you know, we have experts who have not only designed and commissioned plant, but experts who have run and operated plants. So we get better operational perspective than some of the OEMs which provide the technologies. All right. We also do hot air recirculations on the waste heat recovery. We have done 5 projects completed across UTCL, JK, and others. And across all the types of coolers, you know, from FLX and IK and etc., with significant savings, you know, right up to 0.5 megawatt. We have ongoing projects in 3 plants in Ultratech, Dalla, and Rajeshri. We also have done alternative fuels for Narmada, you know, firing systems up to 10% AFR. On the waste heat recovery, we have done the waste heat recovery with the new AKC boilers, etc. So we have a spectrum of solutions where we work our own internal process designs as well as with the OEMs. Overall impact, you know, at the moment, as we say, we are young, but we are leaving a significant impact. As of today, our customers are saving roughly 65,000 tons per year of CO2, almost 27,000 megawatt of power every year, and roughly almost 1.3 trillion kilocalories of power savings that we have brought to our customers. Right. For any other inputs, I'm available, and you can have a look at our website for further details. We'll be happy to serve you. Thank you.
Thank you very much, sir. Thanks for sharing your rich experience and then also highlighting the various opportunities available in the plant and then the opportunities available in the existing plants to upgrade them to meet the current challenges. Thank you very much, sir. We will post any query or this thing from the participants, and I will also share your contact details with them.
Thank
Sir,
you.
we have a few questions. The first few questions are addressed to Mr. Shivakumar. Sir, the specific question was like, is there any prerequisite for the effective functioning of ABC? So, because he is the participant has mentioned that in some of the plants they were not able to get the desired benefits. Is there any prerequisite or is there any general condition? The other question is the one more question is a general question. Maybe the role of food draft in kiln and cooler optimization. Maybe you can briefly tell. Yeah, thank you, sir.
Yeah. Regarding the first question, the ABC inlet capable of handling even the difficult raw mix plant, where the build-ups area is much more prone than the normal plant. So, more the problematic raw mix we have, the benefits will be much more higher. But as I was slightly highlighting the point that ABC inlet benefit will be able to reach long term, much more than a single day operation. So, because of the nature of the operation point flexibility, the convenience the operator have to make the bed higher depth. Higher the bed depth, better the heat recuperation efficiency. But what prevents them to operate like that is the fear factor of buildups. Fear factor of snowman. So the ABC inlet is going to give the flexibility to them to have the control in a better way. So it's linked with that. Definitely in long term, if you see, you will be able to take the benefit. And it is proved even for difficult to operate plant with difficult raw mix also, the benefits are achieved. So that is one point. The other question is, what is that other one regarding the optimization of hood draft?
Yes, sir.
In general, why we are keeping the hood draft slightly negative is we should not have a positive point there because it is a risky environment. With the clean inlet area, if you see that there will be a lot of openings there visibly seen also in some plants where you should not end up in positive draft where the heat will come out. So always safer is to have the negative draft maintained there. But if it is too much negative, what happens is you are going to take too much air than required for O2 control into the system. So any air, even from the cooler, it is going back to the system. It has some heat content, but the entire the air has to be raised to a temperature of burning zone and then go out, which may not be required. So more the hood draft negative, definitely we lose fuel. So we have to make sure that it is maintained negative always, but with a safe limit, but it should not be too much.
Thank you very much, sir. Thank you. Sir, once again, on behalf of Chairman, I think because of the net issues, he was not able to continuously join. So on behalf of Chairman and behalf of CII and other participants, I thank all the speakers for sharing their rich experience and knowledge. With this, we will close the session, sir. Thank you very much. Thanks for joining.
Thank you.
Thanks
Thank
to
you,
all
sir.
panelists.
Thank you.
You can give now.